Today we're going to finish the zero product property. So today's 421, and you'll need yesterday's notes to finish up. Let's go back to example number 5. Here's a quadratic function. We have a term on the left and a term on the right. So the first step in the procedure is to put all the terms on the same side and set it equal to 0. So we want to subtract 3x. Now, when I look at this function, I have to decide if there's a greatest common factor that can be removed first. And as I look at each term, I can see that they each have an x. So I'm going to remove x as the GCF, and I do have 2x minus 3 left over. And again, it's still equal to 0. At this point, the leftovers are not factorable anymore. So I'm going to set each factor equal to 0. The first factor is x. So x could possibly equal 0. When I sub this into the original function and check it, I do get 0 equals 0 on each side. So this one works. The next factor is 2x minus 3. I'm going to set that equal to 0. We'll add 3 to each side first, and then we'll go through and divide by 2. So we have an answer of x equals 3 halves. So our roots are at 0 and 3 halves. Let's check to see that 3 halves works. If I sub it into the left side, when I squared, it would be 9 over 4. And then I'd be multiplying by 2. So I would have 18 over 4, which reduces to 9 halves. When I sub it into the left side, 3 times 3 halves is also 9 halves. So it does work in balance. So I'm going to write my solution set, SS, as 0 and 3 halves. So these are the locations of zeros on my graph. For the next problem, we're going to jump to example number 7. It says if one root of the equation x squared plus 3x plus k equals 0 is -1, what is the other root? What they're doing is telling me that x equals -1. So they've partially solved the function. What we're going to do, though, is we need to find the value of k. So we're going to first sub -1 in for x and see if we can solve for k. So don't forget, when you sub in, we want to use parentheses, especially around a negative number. So I'm going to have +1 minus 3 plus k equals 0. And we're just going to simply solve for k at this point. I'm going to combine like terms. And I know that k is 2. So now we're going to follow up and finish this equation. We're going to place the value of 2 in for k, and then solve the quadratic the way we've been doing it for the last couple days. So there's 2 in place of k. I don't have a greatest common factor to remove from this trinomial. So what I want to do is find factors that will multiply to 2 and add up to 3. And we only have one set that will work, and that's +1 and +2. So there's my 2 binomial factors set equal to 0. And then we're going to set each binomial by itself equal to 0. So when I go through and set this up, I have a root at -1 and a root at -2. If I sub it in to check, I already know that the -1 will work. I'm only going to check the -2. So I would have 4 minus 6, which is -2, and then +2 is 0. So that does check. So the solution set would be -1, -2. In the final example, they want us to write an equation in the form of ax squared plus bx plus c equals 0, which is a quadratic function, so that the solution set will be -2, +7. We're going to work backward with this problem, and we're going to start with the end and move forward. So since I know the roots are -2 and 7, I'm going to start with the end process, x equals -2 and x equals 7. Now the step prior to this had 2 binomial factors set equal to 0. So what I'm going to do is add 2, so that it's equal to 0, and I'm going to subtract 7 so that the other root is equal to 0. These are your binomial factors, so let's write it as a product. Now I'm going to go ahead and distribute. So I'm going to multiply x times x, negative 7 times x, 2 times x, and 2 times negative 7. So I'm going to get 4 terms, and I'm going to clean this up by combining the like terms in the center, and there's the quadratic equation in standard form. The homework that goes with part 2 of this lesson is homework number 102. You'll see at the top it says solving cubic equations. That's not really what we're doing. You're going to start with 1 and 2. You're only going to complete the problems that I've circled, but please show all work on separate paper. When you're all done, scan it in to a PDF and you can send it to me. If you have any questions, make sure you send me an email or give me a call so that I can help you figure out the tough spots. Otherwise, have a great day.